Hi, my name is Aleix Martinez, and I'll be the instructor for this course. So, welcome. Before starting Silly AI, I was a director of science at Amazon, where I led a science team in the US, mostly based in Seattle, and another one in Europe, mostly based in Barcelona. And before Amazon, I was a full professor at The Ohio State University, where I spent 20 years doing research, teaching AI, and graduating a lot of PhD students in AI. And before Ohio State, I was at Purdue, and before Purdue, I was at Sony Computer Science Lab. And before that, I did my PhD in AI in the late 1990s. So it's been a long run. I have about 30 plus years of experience working in AI, teaching AI, and helping companies adopt AI in their industries. And the reason I wanted to build this course was because, I was surprised, probably not too surprised, but surprised nonetheless, that 95% of pilots, AI pilots, of trying to adopt AI into industries are actually failing. And I know why they're failing. They're failing for a variety of reasons where people don't understand. They don't really know what AI is and what it's capable of doing. And we need to teach that to you and to the people that want to adopt AI so that you and your businesses can be successful. So we have created this course with a gazillion of different tools for you to really do that learning. So we have the video lectures. This is the main component of the course. It's an 11-hour-long video lecture where I cover all the different topics that are important for the AI adoption, for you to understand what AI is, what it's not, what it can do, and what it cannot do. And then we also have a podcast version of the same video lecture. So basically, this is the audio version of the lectures where you can just download them to your phone, your favorite podcast app, and you can just take them on the go. When you commute, when you walk the dog, when you go to the gym, you can just listen to the lectures over and over again until this information gets absorbed and you are confident that you understand the nuances of all the different topics of AI that require for this correct adoption. And in addition to that, we have an ebook that basically has the exact same information, but in written form, but with lots of links for whatever you want to do a deep dive, right, on each specific topic, as well as an audio version of that book. So again, you can just listen to the book on the go. Now, the video lectures are divided into 5 different lectures, right, of about 2+ hours each. The longest one is the last one, the execution, because it's such an important lecture. But we start with lecture 1. This is the introduction. This is where we review why. Why is AI adoption failing and why it succeeds in some places? And topics here include the strategic path to AI adoption, AI productivity. That means the top versus the bottom performers. And that's both for people, the top versus bottom performer employees, as well as companies, the top versus bottom companies. And that will lead us to describing the Matthew effect, which is an effect that actually explains this dichotomy between the top and bottom performers. This will also lead us to describing the right talent, which is the right talent that we need to have in our company, we need to hire, we need to surround ourselves with to be successful with AI adoption. And we'll review humans versus AI, humans being those end-to-end solvers versus AI, which is nothing else than productivity tools. And we need to understand the difference because a lot of AI failure or adoption failure comes from that misunderstanding. Then we will review reducing costs versus the risk of obsolescence, right? Becoming an old company that's completely obsolete. Then we'll review the importance of data. This will include data curation, ontologies. We'll have a lot to say about ontologies and why without ontologies, AI adoption typically fails. And that will then lead us to describing AI agents, AI governance, AI cybersecurity, and expectations versus reality. What do people expect these days from these AI adoptions and what's actually realistic? And finally, we'll quickly review data centers in lecture 1. Then, as we move to lecture 2, we will start doing a deep dive on the mechanistics of AI. We'll start with generative models. That's what people now call generative AI. And here we will start by first introducing what machine learning really is, what neural networks are, what deep learning is. And that will lead us to specific or very in-depth definitions of feature spaces, embedding spaces, the encoder-decoder architecture that is foundation to understanding all these AI models. And within the encoder-decoder architecture, linear projections versus nonlinear mappings. We'll spend, of course, most of our time on nonlinear mappings because that's what modern AI tools use. And those include autoencoders, GANs, that's generative adversarial networks, diffusion models, and so on. This will also include X to Y models, where X is the input and Y the output. So what X to Y model is very important to understand the different nuances and different types of X to Y models that we have. And then we'll start talking about problems and solutions. So for example, we'll talk about regression to the mean, which is a enormous problem. We'll talk about the misunderstood Jevons paradox and why this is so important to understand AI and AI progression. Why generative models fail. We'll include hallucinations and misses. And here we'll introduce the well-known retrieval augmented generation, or RAG, which is a classical solution for some of these problems. We will then review scaling laws. We'll also talk about why large models seem to be smarter or are smarter. And this will lead us to the description of distillation and double descent, which are important topics here. Then as we move to lecture 3, we will talk about foundation models. And here we will start by describing autoregressive models. These are the models that Markov, a famous statistician, introduced many, many years ago, which is predicting the next token, basically. And that will lead us to the definition of transformers. We will spend time describing the encoder part of the transformer and the decoder part of the transformer, as well as describing differences or different types of architectures, whether we increase the depth of the transformer, the neural network, or the width of each of those layers in the neural network. And we'll spend time understanding why there is a difference between the two and what should we do to be successful, or which model should we integrate. And that will lead us to defining frontier models, which are the latest models, the largest models that you have seen out there. And then we'll do deep dives on text embeddings, context windows, pre-training and post-training, rejection sampling, reinforcement learning and reward models, and constitutional AI. And then we'll go back to some of the problems that we had described before in cybersecurity. So we will spend time describing red teaming, model merging, reasoning models, theory of mind, how software developers are actually going to improve with AI adoption, solutions to regression to the mean that we've described above, deception, AI deception that is, and its solution, and mixture of experts. All right, that's a lot already, but then in lecture 4, we'll go deep into wrappers. First, we will describe what wrappers really are. We will explain why that's where the ROI really is, not in foundation models, but in the wrappers on top, built on top of those foundation models. We'll describe general versus targeted solutions and niche industries, which is where the money is to be made. And here we will go into detail on open source versus open weight models. And then we will switch to the fundamental topic to understand why AI adoption is failing, finite versus infinite games. We will spend a lot of time describing how to model finite games and how to model infinite games. And then after that, we'll talk about how can we measure the success of those modelings. And that will include specific metrics that are useful for us to define that success, as well as A/B testing. Then we will talk about successful strategies for AI governance and cybersecurity in these environments. And one specific topic we'll dive deep into is an invitation is all you need, which is a specific security issue that has been defined very recently. And then finally, in lecture 5, which is the longest one, as I said, it's about 3 hours long, we'll talk about execution. We'll start by talking about the famous sentence that probably the most uttered sentence in Silicon Valley, which is ideas are cheap, it's all about execution. And we will see that ideas are not cheap. But indeed, it's all about execution once you have an idea, but ideas not cheap. So it's a combination of the two. And then we'll talk about how to choose a model, how to choose an embedding, how to choose your accelerator, how to create data pipelines. We will talk about the limitations and the concerns about copyright laws and what the implications of those laws are. We will describe how to execute by focusing, right? How to focus. So for example, we'll talk about how to start small. We'll also talk about the key to success, which is hire a seasoned AI expert that can guide that success. And then we will go into who will succeed of the people that you already have at the company, the ones that you work with, the ones that you want to hire, or yourself, right? Who will succeed in this AI transition. And that will lead us to describing the age of specialization. You might have thought that we were already specialized enough. Well, even more so in that AI era. And this will lead us also to describing the famous Dunning-Kruger effect, which we have to be aware of. And then we'll turn our attention to mechanisms to identify that right talent, hire, retain, and promote that right talent. This will also lead us to describing the solo paradox. It's not a very well-known paradox, but it's a foundation paradox to understand how AI adoption is failing right now. Then we will talk about the role of the product manager, the PM, strategic thinking, how the PM and MLEs, machine learning engineers, have to interact to succeed, and what makes for a great manager as well, right? Not just product managers, but managers in general that lead the specific teams, AI teams. And then finally, we will cover the next AI frontier. These are topics that we should be very aware of that are evolving rapidly in 2026 and beyond. We will talk about the power law because we will have to describe most of the models are based on Gaussian distributions, as we will see throughout the course. But we'll talk about the power law and why that is important, which will lead us to search engines and the different issues that we need to be aware in search engines, as, for example, the verification asymmetry. We will close with AI slop and execution strategies to solve some of these problems. As I said, there are other resources other than the video lectures to help you iterate or, go around all these different topics. This is a lot, as you can see. So I believe that it's necessary to have also the podcast after you watch the lecture. Ideally, you want to listen to the podcast, maybe then you want to go back to the lecture to really extract as much information as possible, and then go into the book or the audiobook to supplement that information. I hope you like it, and I hope to see you in lecture 1.